Hello guys, welcome back to my channel. Today I'm going to be launching a new video series, and this new video series is going to be mainly about the SAT math problems. And today specifically we're going to talk about and try to solve problems about the substitution problems. And the difficulty of these problems are going to be ranging from easy to hard. Alright, so let's get started. Let's take a look at the first problem. In the first problem what we have is, by how much is the greatest of 5 consecutive even integers greater than the smallest among them? So basically we can select any 5 consecutive even integers starting from, let's say, 2, 4, 6, 8, and 10. So that obviously the smallest one is 2 and the greatest one is 10. So basically this problem is actually asking you to figure out the difference between these two numbers. So basically the difference will be 10 minus 2, so we get 8. So that's the correct answer for the first problem. Alright, okay, let's move on to the second problem. And the second problem, it says, which of the following could be an integer? Okay, again, if we choose some random consecutive integers like 3, 4, 5, 6, 7, and 8, okay, and then let's try to apply each of these answers, okay, and try to get the correct answer. All right, in the first one it says average of 2 consecutive integers. Okay, so let's choose any 2 consecutive integers. Okay, 3, 4. 3 plus 4 divided by 2, we get 7 divided by 2, which is 3.5, which is not an integer. Okay, let's select 5 and 6. 5 plus 6 divided by 2. So we get 11 divided by 2, we get 5.5, again, not an integer. Okay, so basically my first answer choice is not going to be working out well for us. So basically I'm going to eliminate that. Alright, let's move on to the second answer choice. It says average of 3 consecutive integers. Alright, let's choose 3, 4, 5. So we get 3 plus 4 plus 5 divided by 3. So we get 12 divided by 3. So answer will be 4, which is an integer. Okay, but we need to also try other 3 consecutive integers. So let's choose 4 plus 5 plus 6 divided by 3. So we get 15 divided by 3, and then we get 5, also an integer. All right, let's choose 6, 7, 8. So 6 plus 7 plus 8 divided by 3. So we get 6 plus 7 is 13 plus 8 is 21 divided by 3. Answer is also an integer. So basically the correct answer for this problem is answer B, average of 3 consecutive integers. You can also apply this in other answer choices, C, D, E. For example, average of 6 and 9. 6 plus 9 divided by 2. So we get 15 divided by 2, which is 7.5, which is not an integer. It's a decimal number. Okay, so we can also eliminate that. Average of 6 consecutive integers. So if you add them all up, okay, so you get 3 plus 4, 7, 12, 18, 25, and 33 divided by 6. Basically 33 is not divisible by 6 evenly, so that's why answer will be decimal. This is also wrong answer. Average of 4 consecutive integers. 3, 4, 5, 6. So 3 plus 4, 7 plus 5, 12 plus 6, 18. 18 divided by 4, that's going to be 9 over 2, which is another decimal, which is not an integer. Basically, our correct answer is B for question 2. Alright, hopefully I'm helping you out for these problems. Alright, let's move on to the question 3. In question 3, it says the average of 5 consecutive integers starting from n. In this case, okay, so let's say the first consecutive integer is m. Another one will be m plus 1 because it doesn't say consecutive even integers or consecutive odd integers. So basically we can select any consecutive integers. So m plus 1, m plus 2, m plus 3, and lastly m plus 4. So these are the 5 consecutive integers. So if I try to figure out their average, so if I add them up, okay, if I add them up and divide it by 5, let's see what we're going to get. So basically we're going to get 5m plus 10 divided by 5. So that's going to be equal to just m plus 2. So that's the average of 5 consecutive integers starting from m. All right, so in this case, it says also average of 6 consecutive integers, which means I'm going to be adding another consecutive integer, which is m plus 5, and divide this sum by 6. And that's going to be equal to, 6m plus 15 divided by 6. If I simplify it, it'll be equal to m plus 5 over 2. So basically, it's asking us to find the difference between them because we see this different minus sign. So the difference between them will be m plus 2 minus m plus 5 over 2. And apparently, these m's are going to cancel each other out. So the answer will be 2 minus 5 over 2, or negative 1 over half. Negative 1 over 2, or negative 1 half. So that is the correct answer for B. Again, you see that I'm doing all these substitution problems so far, like you're using the substitution method. So basically, starting from m integers, the next integer would be m plus 1, another integer would be m plus 2, and so on. All right. Okay. So now let's move on to the question 4, which is one of the hard problems in this problem set. Okay. In this one, it says the remainder when the positive integer m is divided by n is r, and what is the remainder when 2m is divided by 2n. So in this case, since this is a special case, so we can select numbers for m, n, and r. So let m be 15. Okay. So let's say the m is 15. All right, and n is equal to 4. So if I divide 15 by 4, okay, so my remainder will be 3 plus 3 over 4. So my remainder will be 3, which means r is going to be equal to 3 if I divide 15 by 4. Okay, so when you divide 2m, so 2m is going to be equal to just 30. When you divide 2m by 2n, which is 2n will be also 8. So 30 divided by 8. Okay. So as you know, obviously 30 is not divisible by 8 evenly. So it's gonna produce a remainder. So when you divide 30 by 8, the result will be 3 plus 6 over 8. Okay. So in this case, this is going to be my remainder. So my remainder will be 6. And my first remainder is 3. My second remainder is 6. So what is the relationship between them? So basically, we just doubled the remainder, the amount of remainder. So basically, it has to be 2r. Okay, so that's the correct answer for question 4. All right, let's carry on to the next problem. In this problem, it says if 1 is less than p less than 3, then which of the following could be true? So since p could be any number falling in between 1 and 3, so basically we're going to have 3 cases. So we can select any number that is going to be falling in between 1 and 3. All right. So let's say that let p is equal to 3 halves first. Then let's apply all these conditions. So 1, so p squared will be 9 over 4, and 2p will be 2 times 3 over 2, and now we get 3. Is p squared, which is 9 over 4, less than 3? We know that 9 over 4 is equal to 2.25. Yes, 2.25 is less than 3. So that is correct for 1. But since 9 over 4, which is p squared, is less than 2p, basically this p squared cannot be equal to 2p. And p squared cannot be bigger than 2p, because this number 3 over 2 only satisfies the first condition. So basically these two are going to be wrong. Okay, so let's say if my number p is equal to 2, so what is going to happen? Let's see. So if I apply the condition 2 squared and then 2 times 2, so basically 2 squared will be 4 and 2 times 2 will be 4. So there's only one condition that is going to satisfy this situation, is this equality. Okay, so basically if the number p is equal to 2, and it's going to satisfy only the second condition. Okay, and then let's try another number for p. So let's say it is going to be equal to 5 over 2. So let's say p is equal to 5 over 2, and let's figure out what is p squared. That'll be 25 over 4, and that's going to be equal to 6.25. And then let's try to figure out 2p, which is 2 times 5 over 2, which is 5. So it turns out that 6.25, which is p squared, is greater than 2p. Okay, it's going to satisfy only the third condition. Okay, so basically, if I make a conclusion about these 3 different cases, so what I'm going to say that clearly, so one of the 3 answer choices are true simultaneously for any value of p that we can select, and that is going to fall into the given interval. So basically, answer is going to be equal to E for any p values that we can select, because we ended up with 3 different cases, and we tried those numbers for these conditions. So the answer is E. All right, let's move on to question 6. In question 6, it says that if 42.42 is equal to k times 14 plus m divided by 50, so where k and m are positive integers, and m is less than 50. So what is the value of k plus m? So in this case, let's suppose, again, we're going to come up with easy and manageable numbers for k first. So basically, we're going to apply substitution. So I'm going to plug in, let k be 1. So basically, I'm going to be plugging in 1 for k into the problem. So let's see how it's going to turn out. All right. So 42.42 will be equal to 14 plus m divided by 50. And from here, so if I subtract 14, we get 28.42 will be equal to m divided by 40. So if you multiply 28.42 by 50, clearly it's going to be a number that is going to be way bigger than 50, because we have this restriction. M cannot be bigger than 50. So basically, k cannot be equal to 1. All right. So let's try if k is equal to 2. So 42.42 is equal to 2 times, so let me quickly clean up this part. Okay. So 42.42 equals 2 times 14 plus m divided by 50. So if I divide this side by 2, we get 21.21 equals 14 plus m divided by 50. If I subtract 14, we get 7.21 equals m divided by 50. Again, if you do cross multiplication, and the result will be, again, way bigger than 50. Apparently, I'm not going to put the numerical answer right here, but it's going to be, apparently bigger than 50. Okay, so we have to abide with this this given restriction, all right? So k cannot be equal to 2. All right, let's try k equals 3. All right, so that's going to be equal to 42.42 equals 3 times 14 plus m divided by 50. If I distribute 3 into the parentheses, let's see what's going to happen. So 42.42 will be equal to 42 plus 3m divided by 50. If you subtract 42, you get 0.42 equals 3m divided by 50. So basically m is going to be equal to 50 times 0.42 divided by 3. So I'm not going to put down the numerical answer, but it's going to be clearly less than 50. So let's try to figure out this value. So m is going to be equal to, m is going to be equal to 7 for this. Okay, so when k is equal to 3, m is equal to 7. So the question is asking us to find the sum of them. So basically 7 plus 3, so we get 10. 10 is going to be our correct answer. Okay. All right, let's move on to the our last problem. It says if p and q are both positive integers such that p over 9 and q over 10 is also an integer, so then which of the following numbers could be p is equal to? So since p and q are positive integers and we want p over 9 plus q over 10 to be an also positive integer, so p must be 9. So there's only one possible number for p that is going to satisfy this situation, that is going to make this expression integer. Okay, so basically p must be equal to 9. Otherwise, for other values of p that we can select, we're going to end up with either repeating decimals or non-terminating decimals. Alright guys, thanks so much for watching this video. See you in the next video. Please stay tuned. Bye-bye.